Okay, in this lesson, we are going to just kind of be simplifying some fractions that have rational expressions in them. Okay, so we're going to need to remember how to factor and how to deal with domains and ranges and all kinds of good stuff. Okay, so here we go. The first thing I want you to do is I want you to remember some things about domain, okay? So this first one, if you remember, 3x squared minus x plus 5, if you just think about it algebraically, because it has an x squared in it, it's a parabola, okay? And it's an up and down parabola. In fact, this one does open up because your a right here is positive. And if you think about it, your domain is every single number from left to right. There is not a number that I can't put in for x. So your domain in this case would actually be all reals. I'm going to use that symbol for all reals. If you want to write it so that it goes from negative infinity to positive infinity, that's fine too. Okay. In the next example, I want you to remember that you cannot have a negative number underneath the square root symbol. Okay, so the smallest this quantity right in here can be is 0. So what I'm telling you is x minus 1 has to be greater than or equal to 0. Add 1, x has to be greater than or equal to 0. Okay, it has to be. Or if you want to write it 0 to infinity, that's fine too. I can plug in any number from there to there. Okay, and the next one, the key thing to remember is that you cannot have a 0 in the denominator. So x minus 2 can't be 0, which means that x can't be 2. Okay, x can be any number but 2, and that's how that works. Okay, if you plugged in 2, you would have a 0 in the denominator, and that could not happen. This is just a quick reminder of the formulas for the sum and difference of cubes. I know you've done these many times before, but they are formulas that people tend to forget, and so I need to remind you of them. Okay, and we'll use it in just a minute. All right, so here's two fractional exponent or fractional expressions that I want you to be able to divide. Remember that when you are dividing in here, that you are multiplying by the reciprocal. Okay, if you're multiplying, you just multiply. But if you're dividing, you multiply by the reciprocal. What that means is that the first fraction does not change. Okay, first fraction will stay as is. But the second fraction, I switched the top and the bottom. So this becomes x cubed minus 8 over x squared plus 5x minus 14 instead. Okay, so that fraction, second fraction, gets made into a reciprocal. All right, now I'm going to factor these if I can. Okay, so I'm first of all going to factor this trinomial right here. Okay, that one should factor like this, we hope. Remember, your fronts have to make your front, your backs have to make your back, and it does factor into minus 3 and plus 7. Okay, then I am going to look at this trinomial right here. Remember that to factor, the first thing you should always look for is if you have any common terms that you can pull out. And I can pull an x out of here. And when I pull an x out, I have x squared plus 2x plus 4. Okay? Lots of people think that that can be factored even more into x and x to 2. But hopefully you realize it doesn't factor. 4 and 1 doesn't factor either. Okay, so there's nothing more that I can do with that one, although you may get some in your homework where you can do more with it, so just pay attention to that. Okay, then I will take this. This is a sum and difference of cubes. So this is obviously x cubed minus 2 cubed. Okay, so your a is your x and your b is your negative 2. Okay, so here we go. This is how this factors. It factors as a minus b, so that's x minus 1. And then a squared, so x squared. Whatever this sign is right here, this is a minus. The next one will always be the opposite, and that's a plus. Okay, so then I'm going to take 2 times x and get 2x. The last sign is always a plus. And I'm going to take negative 2 and square that, and negative 2 squared is 4. Okay. And then lastly, I will take this and factor it. Okay, and I have an x and an x 2, 7 plus 7 minus 2. All right, so at this point, and actually I probably should have factored first and then flipped this, but here's the deal. What I want you to look up for are things where you have zeros in the denominator, okay? Places where you would end up with zeros in the denominator. So for instance, right here, this one right here, x can't be 2 because that would make my denominator 0. Okay, so I know that x can't be 2. I know that x can't be negative 7. Here, right here, I know that x can't be 0. Okay, and actually, if I had this flipped around from the beginning, okay, if I had that flipped around from the beginning, like it was here, okay, these two were flipped around, right? And in the beginning, those two were flipped around. So what was this numerator right here was my denominator. So x actually can't be 1 either. Okay, then I'm going to take and I'm going to simplify this, and we'll do another example where we look at what x can't be in a minute. Okay, but here's the deal. I'm going to cancel what I can. Okay, so I know that this quantity cancels with this one. I know that x plus 7 cancels with x plus 7. I know that something's not right. What did I do? Nothing. Oh, this should have been an x minus 2 right here. That's what I did. That should have been a 2. Sorry, because 2 is 8 cubed, and I was doing the difference of cubes. Okay, that should cancel with that. Sorry, sorry, sorry. So you know what? That means this is null and void. Okay, sorry, I screwed up. We'll do another one. You'll be okay. You'll be okay. What I have left is this. I have this 2x minus 3 left. And I have this x left that didn't cancel with anything. Okay, and then x can't be 0, negative 7, or 2. Okay, we'll do more. You'll see. All right, here we're going to add and subtract. When you add and subtract, you need common denominators in order to add and subtract, okay? So we will get common denominators here. I'm going to start by factoring these first. So on this quantity right here, I can pull an x out, and then I will have x minus 2. This obviously is just x, okay? And this one factors as x plus 2 and x minus 2, okay? Right away, I'm going to look at my denominators, and I'm going to look at what would make my denominator be 0, okay? Because any denominator anywhere along the way can't be 0. All right, so I know right here that x can't be 0. I know right here that x can't be 2. And I know right here that x can't be negative 2. Okay, that covers all of those. So in the end, I'm going to need to have those restrictions on there. Okay, I am trying to add these fractions, and so I'm just going to rewrite this because it's just a little bit sloppy right now. And this is what I have. I have 2 over x times x minus 2 plus 1 over x minus 3 over x plus 2, x minus 2. All right. Now we want to get our common denominators. So if you look at those three fractions, the common denominator would be x times x minus 2 times x plus 2, because those are all the different denominators that you have, okay? This first term right here has the x, and it has the x minus 2, but it does not have the x plus 2. That's the piece it's missing, so I'm going to multiply by that, okay? The next term has the x, but it does not have the x minus 2 or the x plus 2. Okay, so I need to multiply top and bottom by that, so that's like you're multiplying by 1. The last term has the x plus 2 and the x minus 2, but it does not have the x. Okay, so then when I distribute this, I have 2x plus 4. and then I have 1 times this quantity right here, and I am going to FOIL that quantity out. When I FOIL that quantity out, I have x squared minus 4, okay? And then be careful because you really have negative 3 times x, which is negative 3x. My common denominator is x plus 2, x minus 2. Okay, so now I'm going to simplify the top as much as I can. Okay, if I simplify the top as much as I can, then I have an x squared minus x on the top. Okay, x squared, my 2x and my negative 3x make negative x, 4 and negative 4 cancel each other out. So that's what I have on the bottom, or on the top I mean. My bottom is x times x plus 2, x minus 2, okay? Then on the top, I can factor an x out of here, so I have x times x minus 1 over x times x plus 2x minus 2. Okay, it doesn't look like that got us much, but it does allow us to cancel our x's out. And then that leaves us with x minus 1 over x plus 2x minus 2. And you can just leave it right like that, okay? And then remember way at the beginning, we said the things that x couldn't be, and those were these right here. So we need to make sure that we get those in our answers also. X can't be 0, 2, or negative 2. Okay, and that's what that one should look like. All right, then we have another little thing we need to look at, okay? Here I want you to notice that I have a quantity x plus 2 that's in the denominator, so I know right away that x can't be negative 2. I have the quantity x minus 3 in the denominator, so I know that x can't be 3. And I may come up with some more restrictions later, but for now, I can see that right there. Okay, this is a little more complicated to simplify, but I want you to think of just the top for right now, okay? We're ignoring the bottom, and I want to do just the top. This is over 1, okay? So if I were doing just the top, I would need to multiply by my common denominator, which would be x plus 2. Okay, I will distribute that 3 through. And so then on the top, I will have 3x plus 6, and then I have minus 7 right there, all over my common denominator, which is x plus 2. Okay, so that's where I'm at right now. On the bottom, okay, I'm going to think of just this part right now. This is 1 over 1. I would need to multiply by my common denominator, which is x minus 3. Okay, so I have 1 times x minus 3 is x minus 3, and then minus 1 over my common denominator, which is x minus 3. Okay, now I'm going to simplify these a little bit. So on the top, right here, I will have 3x minus 1 over x plus 2. On the bottom, I will have x minus 4 over x minus 3. Okay, now you've got a double fraction going on here, and you need to simplify that double fraction. Okay, and so you are going to simplify that by multiplying by the reciprocal. Okay, so when I multiply by the reciprocal now, I'm going to take this quantity right here and multiply by the reciprocal instead of dividing by that fraction. Okay, so instead of dividing by the fraction, I'm going to multiply by the reciprocal. And you can see that nothing cancels out. Okay, now from the very beginning, we knew that x could not be negative 2, and we knew that x could not be 3. Now in the denominator, I can also see that x can't be 4 either. Okay, so this is what my answer is going to look like. There's nothing I can simplify. I can't factor anything out or anything, so that's just what my answer is going to look like. Okay. And the very last thing. All right, down here, right here, I can't have a 0 on the denominator, so A can't be 0. Right here, B can't be 0. Okay, and same thing here. A couldn't be 0 here, and B couldn't be 0 here. So just so you know, okay? Same kind of thing. You're going to multiply this out. Okay, get common denominators. I'm going to look at just this piece first. Here, I will need to multiply this side by b squared over b squared, so that I have common denominators. Here, a squared over a squared. So I have b squared minus a squared over my common denominator, which is a squared b squared. Down here, I need to multiply that by b over b, and this one by a over a, so that I get common denominators. Okay, and then I will have b minus a over my common denominator, which is ab. Okay, so now what you're going to do, I'm going to move these here. Now what you need to do is you need to think about multiplying by the reciprocal. Okay, so I'm going to take this quantity right here, and instead of dividing by that quantity, I will take and I will multiply it by its reciprocal. Okay, so now I'm here. And now some nice things happen. Okay, so first of all, this cancels with one of those, and this cancels with one of those. Okay, then some people think that this and one of these cancel, but that's not what happens. You need to think about this as a perfect square. This is b minus a and b plus a. Okay, that's what I have on the top. And so the quantity b minus a cancels with the quantity b minus a. And what I end up having is b plus a over ab. Okay, and remember, a can't be 0 and b can't be 0. All right, and that should do it for today.